Hello everyone and welcome. In this lecture we'll look at how we can change default properties for our Matplotlib's graphs. Okay, if you haven't, let's start by importing NumPy and Pandas and Matplotlib's pyplot as PLT, and we have our Matplotlib inline special function. So what we'll do is use our previous graphs, the sine and cosine function, and see how we can change some of the default properties. Okay, so in the previous lecture we defined our x and y axis, and we used those points for our graphs. So we used npiece line space method, and we used points from -6 to up to 6, and we consider 200 points. You can change these values if you want, it doesn't matter. Okay, and for our y-axis we use the cosine function for one of our graphs, and we use numpy sine function for the other. So np dot cosine of x, and for sine we used numpy's sine function, right? And we were able to display the graphs by calling Matplotlib's plot method and then passing our x and y axis. And plt.plot x and then sine of x. So if we run this, we get sine and cosine of x on the same figure. So one thing we can do is, so this is the default size of our figure, and there is a function that we can call known as the figure function, and then we can pass an attribute known as fig size, and we can adjust the size of the figure depending on our notebook. So let's call that function. So here what I will do is I'll call the figure function, so plt.figure, and then pass the figure size attribute fig size, and then set it to whatever size fits your notebook well. Let's try 10 by 5 maybe. So let me run the cell again. Okay, it looks nice. So you can adjust it depending on the best fit. Okay, you can change these values. For instance, if I copy this whole thing, paste it here, and let's make it 10 by 7. So you see the difference? This looks like a little bit better fit. So you can adjust it to what fits your notebook the best. Okay, now let's see how we can change some of these default values. For instance, here we have our cosine function, right? Our cosine graph. The blue one is cosine. So in order to make sure that that's the cosine, we can pass some other attributes to our plot function. For instance, we can adjust the color. We can set the color to be equal to, let's say, red maybe. Okay, that's one thing we can do. Another thing we can do is we can adjust the line width by passing an attribute known as line width, and we can set it to a value that we like, let's say 2.0. Okay, let me run this and show you the difference. So if we run this, now we know the cosine plot is in red and the line width is 2.0. You see, it's much thicker than the one in blue, or the sine function. Similarly, we can pass some attributes to our sine plot. Let's use a color of green maybe, and let's also pass a line width attribute. So line width, and let's set it to be 3.0 maybe. Run it. Line width, oh, spelling is not right. Let's run it again. There you go. The green one is for our sine plot, and the line width is 3.0, so it's much thicker than the red one. Another thing we can do is adjust this ticks on our X and Y axis. For instance, here on the X axis, the ticks go from -6 to 6 in step sizes of 2, right? So -4 and then -2, 0, 2, and 4. What we can do is we can pass a function known as X ticks and then adjust the ticks that the way we want it. Okay, let's see how we can do that. So I'll copy this, paste it here, and then I'll call the xticks method. Okay, so we have from Matplotlib, we'll call the xticks method, and let's use NumPy's line space method. And then, so let's say we want 12 ticks from -6 to 6, and then we want, let's say, 12 ticks. So if we run this, so now you'll see 12 ticks from -6 to 6. Okay, that's how we can adjust our X ticks, and we can do the same for our Y ticks. So here by default we have, for our Y tick, we from -1 to 1 we have 3 ticks in step sizes of 0.5. We can change that default by calling the yticks method, and then let's use the same NumPy's line space method, and then so let's use from -1 to 1 we want, let's say, 6 ticks. Okay, run it. So now you'll see 6 ticks, 1, 2, 3, 4, 5, 6, and the step size is now 0.4. Right, earlier it was 0.5. Another thing we can do is adjust our X limits and Y limits for our figures, and we do that by calling the xlim and ylim function. Let's say an example. So plt.xlimit, let's say we want to use points from -3 to 3. Okay, if I run this now, you'll see it's from -3 up to 3. It's no longer from -6 up to 6. Okay, we can do that, and similarly you can adjust the y limit by calling the ylim function, and let's use -0.8 to 0.8. And if you run it, you'll see a graph that looks like this. One example I want to show you, let me make it from -1.8 to 1.8. And if I run this, you see a nice oscillation. And furthermore, you can change this X limit values to, let's say, -8 to 8. So if you run this now, you'll see the graph stops at -6, right? You see it's between -6 and 6. That's because when we defined our graph, here we specified our x-axis to be from -6 up to 6. So it won't be outside of this range. However, the margins of our graph goes beyond those points. That's why you see the difference here. Okay, so that's how we can use the X limit and Y limit, xlim and ylim, to adjust some of the default behaviors for our graph, for our figures. Okay, so try out some of those and see what you can get. Great, thank you everyone, and see you at the next lecture.